Proof of stake is by far the most popular choice for blockchain networks today. But with so many variations, it can be tricky to understand its core concepts. Nowadays, you're unlikely to see it in its original form. Nevertheless, all kinds of proof of stake share the same key core concepts. Understanding these similarities will help you make better choices about the blockchains you use and how they operate. The proof of stake consensus algorithm was introduced back in 2011 on the Bitcoin Talk forum. It was proposed as a solution to proof of work's problems. While they both share the same goal of reaching blockchain consensus, the process they take is quite different. Rather than need to provide a computationally intensive proof, participants only prove they have staked coins. The proof of stake algorithm uses a pseudorandom election process to select validators from a group of nodes. The system uses a combination of factors, including staking age, an element of randomization, and the node's wealth. In proof-of-stake systems, blocks are forged rather than mined. However, you still might hear the term mined occasionally used. Most proof-of-stake cryptocurrencies launch with a supply of pre-forged coins to allow nodes to start immediately. Users participating in the forging process must lock a certain amount of coins into the network as their stake. The stake size determines the chances for a node to be selected as the next validator. The bigger the stake, the larger the chances. Unique methods are added into the selection process to favor not just the wealthiest nodes in the network. The two most commonly used methods are randomized block selection and coinage selection. In the randomized block selection method, the validators are selected by looking for nodes with a combination of the lowest hash value and the highest stake. Since the sizes of stakes are public, the next forger can usually be predicted by other nodes. The coinage selection method chooses nodes based on how long their tokens have been staked. Coinage is calculated by multiplying the number of days the coins have been staked by the number of coins staked. Each cryptocurrency using a proof-of-stake algorithm has its own set of rules and methods combined for what it thinks is the best possible combination for the network and its users. When a node gets chosen to forge the next block, it will check if the transactions in the block are valid. It then signs the block and adds it to the blockchain. As a reward, the node receives the transaction fees from the block and, on some blockchains, a coin reward. If a node wants to stop being a forger, its stake and earned rewards will be released after a certain period, giving the network time to verify that there are no fraudulent blocks added to the blockchain by the node. Most blockchains post-Ethereum use proof-of-stake consensus mechanisms. Typically, each one is modified to suit the needs of the network. These include BNB Chain, Solana, Avalanche, Polkadot. Proof-of-stake has many clear advantages over proof-of-work. For this reason, new blockchains almost always use proof-of-stake. 1. As users' needs and blockchains change, so can proof-of-stake. It's plain to see this with the vast number of adaptations available. The mechanism is versatile and can easily fit most blockchain use cases. 2. More users are encouraged to run nodes since it's more affordable. This incentive and the randomization process also make the network more decentralized. Although staking pools exist, there is a much higher chance for an individual to forge a block under proof-of-stake successfully. Overall, this reduces the need for staking pools. 3. The cost of participating relies on the economic cost of staking coins rather than the computational cost of solving puzzles. This mechanism leads to a significant reduction in the energy required to run the consensus mechanism. 4. As proof-of-stake doesn't rely on physical machines to generate consensus, it's more scalable. There's no need for huge mining farms or sourcing large energy supplies. Adding more validators to the network is cheaper, simpler, and more accessible. 5. Staking works as a financial motivator for the validator not to process fraudulent transactions. If the network detects a fraudulent transaction, the validator will lose a part of its stake and its right to participate in the future. So as long as the stake is higher than the reward, the validator would lose more coins than it would gain with fraudulent activity. To effectively control the network and approve fraudulent transactions, a node would have to own a majority stake in the network, also known as the 51% attack. Depending on the value of a cryptocurrency, it can be almost impossible to gain control of the network, as you would need to acquire 51% of the circulating supply. Although proof of stake has many advantages compared to proof of work, it still has some weaknesses. 1. With a standard proof of stake mechanism, there's no disincentive for mining both sides of a fork. Under proof of work, mining both sides will lead to a waste of energy. With proof of stake, the cost is much less, meaning that people can bet on both sides of a fork. 2. To begin staking, you'll need a blockchain's native token supply. This requires you to purchase the token via an exchange or other method. Depending on the amount required, you may need a significant investment to begin staking effectively. 3. While proof of work is also prone to 51% attacks, they can be significantly easier with proof of stake. If a token's price crashes or the blockchain has a low market capitalization, it can be theoretically cheap to purchase more than 50% of the tokens and control the network. Proof of stake is highly adaptable. Developers can change the exact mechanism to suit a blockchain's specific use cases. Delegated proof of stake allows users to stake coins without becoming a validator. In this case, they stake them behind a validator to share in the block rewards. The more delegators stake behind a possible validator, the greater its selection chance. Validators can usually change the amount shared with delegators as an incentive. A validator's reputation is also an important factor for delegators. Nominated proof of stake is a consensus model developed by Polkadot. It has many similarities with delegated proof of stake, but one key difference. Nominators can choose up to 16 validators to stake behind. The network will then equally distribute their stake behind the chosen validators. BNB Smart Chain uses proof of stake authority to generate network consensus. This consensus mechanism combines proof of authority and proof of stake, letting validators take turns to forge blocks. A group of 21 active validators is eligible to take part, selected by the amount of BNB they stake or have delegated behind them. This set is determined daily, and BNB Chain stores the selection.
If you found this article useful, please consider subscribing to our YouTube channel. You can also visit our website, where you find great educational contents about cryptocurrency. As a member of our Cryptocurrency Academy, you'll have access to exclusive resources and tools to help you stay informed and make better trading decisions. Additionally, discover and join our Discord. Our Discord server will provide a supportive network of like-minded individuals who can provide guidance, advice, and encouragement.